We use label data sets to train the algorithms.
Okay, we use label data set to train the algorithm. We'll call it as supervised. Okay, forget about the machine learning part. Just tell me the actual literal meaning of the supervised and the unsupervised. Then things will get clear. As name suggested, supervised means what? The exams what I'm giving is, we'll call it as it is a supervised, right? Someone is monitoring you, right? Few of the information is available. So in machine learning, we'll call it as the labels are available. Not necessary that each time I will be having the label. If I'm going into the domain of reconstruction, that is, I'm going to generate a particular image, or I'm going to improve the quality of the image, we'll call it as that data is also called as a supervised, in which while training the original data is available with me, right? So if I'm having the particular information available with me, then we'll call it as it is a supervised machine learning. Whereas if it is only the data driven, I cannot deduce any of the information about the data, we'll call it as a unsupervised learning. So what do you mean by unsupervised learning? Proper, or let's say an recent example of this is nothing but in companies, whenever you are going into the banks, I'm submitting my data based on the your spending view. The banks are offering you few of the offers, some type of offer, maybe some type of reward points and so on, right? So how it decides based on your spending patterns, how much money you are spending, how you are spending. Based on that, they are going to identify. So they don't have any of the clue or any of the information about yourself. They only have your data with them, right? So it is unlabeled. From that data, my bank is going to offer some offer or something to the particular customer, right? Third is that I have the reinforcement, in which we will be learning, my machine will be learning from the penalties, that whenever it makes a mistake, we are going to update the weight. Mathematical model will be given, in which I'm going to update the weights. If it is a mistake, I will just penalize it. If it is not, then I will give him the advantage. And that way, my machines is going to train itself, it's going to update its weight, right? So if I'm saying machine learning, it can have the various different subclasses. If I'm saying supervised can be used for the classification, it can be used for the regression or the prediction. Similarly, unsupervised, I can have the different algorithm called as clustering algorithm. I can have the dimensionality reduction. I can have the reinforcement learning to do the game AI or the real-time decisions and so on, right? So these are the various types of domain in which my machine learning works. So as far as we know, machine learning is a broader aspect. It is a universal set. Inside that, we are going to have the different subtype. Inside that, I'm having the subtype called as a deep learning. Inside deep learning, I'm having the one component called as a CNN, right? So machine learning is ultimately the broader view that we are going to have, right? So it is a bird eye view. Inside that, we are going to have the these subclasses always, right? So next, in supervisor, just to visualize it, it's nothing but if I'm having the raw data, if I know the labels, that I'm going to train it, I'm going to derive the output, I'm going to process it, and then I'm going to categorize it based on the information what is available, right? So if I'm just saying I'm giving the images of the apple, pears, and the mango, then I know that how it looks like. Then depending on its features, kind of color, its shape, and its appearances, I can deduce or I can learn, my machine can learn similarly, and it can just categorize it or classify it, right? Now human can learn from the images, right? So whenever I'm seeing it, whenever my eyes are seeing it, I can acquire the knowledge about it. So similarly, how what type of knowledge I can acquire from the given images? When I can say that it is an apple, Yes. What are the features of apple? Features as nothing but a, if my apple is having the color as red and it is having the specific shape like an apple, I will distinguish or categorize it as apple. My tomato is also having the red color, but if its shape is a round or elliptical shape, I will not be categorizing it as a apple. Similar type of features, similar type of appearances will be fed to your computer system. In a normal image processing, these features are known as a shape, color, its dimension, and so on, right? This used to be your normal machine learning or the normal image processing, what we are used to use it, right? So that's why we are going to see the machine learning. So in an image processing, if I want to feed this particular image to the machine, since machine cannot understand anything, I need to tell him the particular color, particular feature. So what are the features of the apple? If I'm saying its features can be color, its shape, its dimensionality, right? Then I can also give the few of the values to the particular shade, that is in a red also. What are the specific kind of red? I will be calling it as a apple. I can have the green apple also. In that case, my machine can get confused between the green apple and the guava or the pears, right? So similarly, I will be feeding him the multiple features that used to be the shape, color, its dimensionality, and so on, right? These features earlier we used to man model, or you can say that we used to extract it manually, right? We don't used to have any of the algorithm. We used to have the normal algorithm called as feature, shape, and dimensionality, which used to be used to extract this kind of information in a mathematical model. Then I will be feeding it to the particular machine learning algorithm, and then it's going to learn it, because my ultimate aim is nothing but my system cannot understand the images. Everything for my system or the computer is nothing but a data in zeros and ones, right? Hence I'm going to feed the zeros and ones information depending on the shape, dimension, and other things, right? Similarly, there can be two types of supervised learning. One is the regression. It is usually used for the classification, right? So it is a problem when the output variable is a real value, such as dollar, weight, wherever I want to do the classification. Then at that time I will be using the regression for the classification. Sorry, for the real time prediction I will be using the regression. For other things I'll be using the classification and the regression, right? So I will be, if I want to classify it, I'll be saying it as a classification problem. So I can have the regression in which I'm going to do the prediction. I need to have the classification in which I'm going to classify the particular problem, right? So what is linear regression? It is nothing but it is a statistical supervised learning technique in which we are going to predict the particular relationship depending on the information what I'm having, right? The classic example will be the weather prediction or predicting the particular house value in a particular area. So if I want to predict the weather, I'll be giving the features such as the past weather record, how was the temperature, what is the wind speed currently it's having, what are the other climate I'm having, and from that I'm going to predict the particular weather for the next day or the for the next following 7 to 1 month days of period of time. Similarly, if I want to predict the particular house value, I'm going to consider the locality, I'm going to consider the age of the house. So these are nothing but a particular features we used to call. So in a image processing or the normal machine learning, we used to feed this information in terms of the values. If I'm saying the age of the house, it will be an integer value that I'm going to feed. Similarly, if I'm saying the locality of the particular house, in order to predict its resale value, I'm going to feed the location using the longitude and the latitude pointers or the latitude information, right? So on, based on that, I'm going to plot a particular line. So a particular model which will be trained is nothing but a y is equals to mx plus c, right? So it is nothing but a equation of the line where b0 and the b1 will call it as a coefficients, and x1 is my features, and I'm going to map it to the y, right? So this is a basic model that my regression uses. Same model will be used in your CNN in order to train the particular system, right? So depending on the X value in the CNN, we'll be having the X as a my image. It will be the, since this is a, for the 1D data, my images are called as a 2D data. So we are going gradually towards the 2D data from the 1D data, right? So one dimensional data is nothing but a simple vector in which I'm only having the one of the dependent variable or the independent variables. From that, I'm going to derive the particular information, right? In a CNN, this X will get replaced with the image, which will be again a 2D type of data, right? So we are going to cover that also, how my actual CNN deduces these values, how it going to learn it from the particular image, right? In order to understand that, we need to start with the single 1D data. Hence, we are going to just quickly touch upon the normal machine learning algorithm, in which first algorithm is a linear regression, which will be used for the particular prediction, right? Second thing is, if I want to have the classification, I'm going to use the logistic regression, in which I'm going to classify it between the zeros and ones strictly, right? So it is used for the classifying the particular type of data. If I just want to classify two types of data, like here in supervised learning, if I just want to classify this raw data, whether it is an apple, guava, or the mango, I can do it with the help of the logistic regression, right? So second is nothing but a unsupervised learning, in which I just have the data. I'm not knowing anything. I don't have any of the knowledge from about the data. At that time, I can just categorize it. I can just cluster it into the different domain, depending on the features or the properties of the data again, right? So in order to do that, we have the various algorithms. You can just explore it. We'll have the well-known algorithm called as k-means, then c-means, and all of them, right? So that is again comes under the normal traditional machine learning, which will be used for the images also, right? So these are, we'll call it as a unsupervised learning, in which I don't have any of the information available about the particular data, right? Similarly, in unsupervised learning, third type of machine learning is nothing but a reinforcement learning, in which I'm going to teach the particular system by providing the feedback, right? Once my feedback is positive, my system will update this weight. If its prediction is a wrong prediction, then it will get penalized. It will be getting the negative weights, right? And so on. My system will deduce the particular weight, and it will be used to do the real-time decisions, right? The same way, these are the this will be used in a real-time applications. Reinforcement learning will be always used, because only training is not enough. I need to learn accordingly. I need to learn continuously as long as my data comes, right? So this type of things can be used in type of the real-time applications. Depending on the applications, we are going to pick any of the three types of algorithms for our solving any of the problem, right? Now, what are the applications of the like reinforcement learning? The games what you are seeing it on the windows, that is the chess game or whatever games we are seeing, or Mario playing itself, all these are the applications of the reinforcement learning. Self-driving cars, they are also getting learn based on the reinforcement learning, right? So reinforcement learning uses the few types of supervised information while training the system, right? So all of these things will need some type of supervision, right? So just to summarize the machine learning, I can just learning can be categorized into the three categories, that is supervised, unsupervised, and the reinforcement. In a supervised, as always, I'll be having the label data. I will be which will be providing the direct feedback, and it will be used for the prediction. Similarly, if I don't have the labels, I don't have obviously the feedback, and it will be used just to categorize based on the raw data, find the hidden structure, trying to learn the pattern from it. Then in the reinforcement, obviously it is a decision driven process, and it is nothing but a reward system. If it is getting the correct, if it is learning correctly, I will just give the reward, otherwise I will penalize my system, right? So it is learning from the decisions what my particular system is going to make, right? Now what are the applications of this? This can have the various application: object detection, object recognition, emotion analysis, speech analysis, stock market analysis, fraud detection, and so on. So out of this, if I'm just concerning about the images, I can have the object detection, object recognition, then object classification, and so on. So these are the actual applications of your machine learning, right? Now we'll just start with the basics of image. So what do you mean by image basically? It is nothing but it will be represented with the help of the matrix, which will be have the height and the width, right? If I am going into the properties of any of the images, it will be having the height and the width defined for the particular images. These images, if I'm having an image, let's say of height 500 and the width as 400, then the total number of pixels that particular image is having nothing but a 500 cross 400. So it's having the almost 2 lakh of images pixel embedded into it. So what do you mean by the pixel? It is nothing but it is the smallest element which represents my particular image. In a system, my image or my computer, it doesn't understand about the images, it just understands the values or the particular numeric data. Hence we'll call it as a basic building block, or the smallest element of the any of the images, nothing but a pixel. So a pixel can be, again it will be represented either with the help of the grayscale image, RGB image, or the RGBA images. Apart from that, nowadays we are also having the hyperspectral images, geotagging images, and so on. So what is basic difference? A grayscale image is nothing but a pixel, which is the smallest element in an image, will be having the values which will be ranging from the 0 to 255, in which 0 is known as a complete black, whereas 255 will be known as a complete white. So I'm having the total 256 shade, which will be ranging from the black to the white. So it gives me the grace color kind of images. Similarly, if I'm just adding the 3 channels to the particular images, which is having again the pixel range of 0 to 255, then we'll call it as a RGB image, that is nothing but a red, green, and the blue channel. Similarly, I can have the RGBA, which is an extension of the RGB images, in which I have added the alpha field, which represents the opacity of the images, right? Again, this opacity will range from the 0 to 1. I can just represent these images. I can normalize these values by just dividing it by 255, in which it will just give me the probability of the number, right? What it means, let's say that for the grayscale images, if I'm dividing it by the 255, then my white pixel will have the value of 1, my black pixel will have value of 0. If I'm having the in between color, that is nothing but a black, neither black nor the white, it is a in between shade, then it can have the value as 0.5, which is nothing but a halfway of the 255, right? So this is how I'm going to represent my particular image, right? So image processing requires the fixed sequence of operations that needs to be performed on the each pixel of an image, right? So if I'm having any particular image, just one sec. If let's say I'm having the digit 1 and this is the image. So if I'm going to represent it in the system into the computer, I'll be having the length given to it, right? So I can also divide this image into the simple, let's say 3 cross 3 width. So what will be the height of this image now? What is the smallest element of the image?
Pixel.
Pixel. So these are the pixel. Height and width will denote the total size of the pixel. So what is the height of this? How many pixels I'm having here?
3.
3 cross 3, right? So I'm having the 3 cross 3 image. If I'm going to represent this particular visual digit 1 into the system, my system will just simply divide it into the 3 cross 3 matrix, which will have the values ranging from 0 to 255, right? So for simplicity, I'm assuming that this is completely filled. So this is, you can represent it as a complete black. This is as a complete black. This is as a complete black. Here it is having the black. Here it is having the black. So it will be forming the one kind of the structure, right? So this is a broader way of the pixel actually. I will be having the millions of pixel in actual image, right? This is just for the representation of the one in which if I'm just assuming that these all pixels are black, this is black, it will give me the, and this is also black, so it gives me the visual appearance as a one. So here what will be the values I will be having into the system? Yes, so first thing here, what should be the value? Assuming that
0.
it is a grayscale image, 0, 0 is a black here, again 0, 0, 0, 0, and 0, right? Rest of the values will be
1.
it will be 255, right? What I'm saying, it is a grayscale image, right? If it is a binary image, I can say that it is having the value as 0 and 1, right? If it is a grayscale image, I can have the shades which will be having the ranging from 0 to 255. So I'm having the maximum value as 255. As we can see that my grayscale can have 0 is a completely black, 255 is completely white. So here I'm having this white background. So this is how my computer interprets any of the image. So whenever I'm saying I'm having the high resolution camera, right? What it indicates? It indicates that whatever values I'm feeding it to the pixel, it is having some particular range. So if I'm in the grayscale, it is nothing but it is 8-bit images. 2 raised to power 8 gives me the 256. Hence I'm having the each of the pixel, smallest element is represented by the 8 pixel. But if I'm having the high resolution cameras, which can capture the 16 bits of information, at that time, what will be the range of this pixel? Two raised to power 16 will be, come on. Yes, some 65,536, right? That many number of pixel information or variation of shades are available with me, right? If I'm just saying the 2-bit, I know that 2-bit can have the 0001, 11, and the 10, that is 4 combination of 4 shades, right? Similar to that, my grayscale can have shades which will be having for each pixel ranging from 0 to 255. If my particular image is a high quality images, it means that my image is getting represented with the help of the higher number of bits, right? So this is how my particular system is going to interpret it. Similarly, color images is nothing but I will be having the such type of grayscale channel which are having the total 3 number of channels. So red, green and blue will be the color associated with the each channel having the values again equals to the 0 to 255. So it gives me the RGB image. Similarly, if I'm adding one more channel to it, I will can call it as a RGBA channel. Similarly, if you are just referring to the hyperspectral images, it is having the multiple images captured at a multiple frequency. So instead of 3 channels, it will be having the multiple n number of channels. So this is my single grayscale image. Grayscale means nothing but the whatever black and white image what we are seeing. That type of image we'll call it as a grayscale image. If it is having the 3 channels such that, then it will call it as a RGB image. If I'm also having the one more channel called as opacity, then it is nothing but a RGBA images, right? So these are the usually how I'm going to represent my particular images. Now, what is my task? I need to acquire the information to train my system. I need to extract the features. So what is features? Feature is nothing but a information or the characteristics of a particular image or the particular matrix what we are seeing. We'll call it as a feature. How a human being understands for the apple, what were the features? If I'm saying apple,
Color and
what
shape.
kind of color and shape, right? Similar to that, I need to acquire this type of information. I need to feed this information to my particular system, right? To particular CNN networks. So that's why I should know how my image is actually being represented. Now, as far as your cameras are considered, how it is going to acquire it? It is going to, my camera is going to just acquire the level of, it's going to bombard the light onto the object. Let's say this was my one. So this is my camera. It used to just plot the light onto it. Whatever light it is going to get back, that value it is going to put it inside the each pixel, right? So it is having the frame something like this. Once the one I'm just clicking the flash, I know that if it is a black color has a property that it absorbs all of the light, hence my naked eye will be saying it as a black color. Similar to that, if I'm putting the light here, if none of the light is coming back, I will put that pixel as a 0. If few of the light is coming back, so let's say I have sent a light which is nothing but a, let's say 1. I'm representing it as a probability of 0 to 1. If 50% light comes back, I will put the value as 0.5. If none of the light comes back, I will put the pixel value as 0, right? So this is how your actual camera works. Now, if I'm just saying that my camera is higher megapixel camera, what it indicates, each and every pixel will be represented with the various number of particular shade. Hence, my image quality will be the improved one. Hence, in checking cameras, we usually give focus on the megapixel instead of the zooming factor, right? So there are mainly the 5 types of image processing that we process it on the image. Now, is it fine? Like basics of the image is clear? Yes, please. How it is going to represent by the system? Yeah, please. Yeah, someone is raising hand. Okay. Okay, we'll move forward then. Now, depending on the images, how it is being captured, we can process the images. There are 5 main types of image processing applications. One is called as a visualization. Second is a recognition. Third is a sharpening or the restoration. Fourth is a pattern recognition. Then the retrieval. If I want to find the objects that are not visible into the image, we'll call it as a visualization. Now, what are the applications of this? If you know, I'm having the various band, right? If I'm just capturing, I'm having the different kinds of cameras, like in case of the X-rays or X-ray machines or the CT imaging, or the MRI imaging. These are the different types of cameras which works at the different frequency, in which few of the objects are visible at some particular frequency, few of them are not visible at the particular frequency. Those type of applications comes under the visualization type of image processing, in which if I'm just capturing the images at the low nano frequency domain, I can also see the water level available inside the surface, right? So that type of visualization can be done with the help of the image processing or the images what I have captured. I used to talk about the hyperspectral images. At that time, my hyperspectral images will have the applications of the visualization. Each and every band will give you the different kind of information. So it will be used in case of the crop prediction, in case of the predicting whether the soil has the water level or not, whether it has the underwater canals or the like some kind of water available or not. This kind of visualization can be done with the help of the image processing. Second type is nothing but a, I can also apply the recognition, which will be used to detect the objects in an image. A simple thing is I can say that I can also do the attendance based system. I can design the attendance based system. Then we'll call it as it is a image processing or the it is a recognition kind of domain. Third domain is nothing but a sharpening and a restoration. If I'm having the low quality images, if I'm trying to enhance that particular images, we'll call it as a sharpening and the restoration. Similarly, if I want to measure the various pattern around the particular object, we'll call it as a pattern recognition, right? Usually this will be used in case of the metal industries, wherever they will be having the different kind of texture which is not visible to the human naked eyes, and I want to know the pattern, particular pattern available onto that texture to detect the fault available on the particular object. At that time, I will be using the pattern recognition type of image processing algorithm. Then the fifth one is a retrieval, in which I'm going to browse and the search image from the large data set, which will be giving me the similar kind of images of at that of the original image. This is also called as a content based image retrieval, right? So these are the broad categories or the you can say the different types of applications that will be using the image processing. So depending on the application, you are going to choose any one of the domain, right? So depending on that, we have various algorithm. So you can choose any of the domain for your particular projects, and then you can go forward into the learning the image processing itself is a broader area, right? Now, what are the basic components that we need at the time of processing an image? We need a computer, we need a hardware which will be specialized in the processing the images because it is a 2D matrix. It takes the massive computing power, right? So we need the GPUs, we need the particular high-end systems to process the image processing data, right? We need the monitor, then the camera sensors. It can be your laptop sensor. Nowadays, my image processing system is already ready on my laptop because I'm having the camera, I'm having the display, I'm having the softwares that are needed. We need Python, MATLAB kind of softwares. And if you want to print it onto the other media, we'll call it as a we'll need a printer and all everything, right? If you are working on the transferring the data, we need the networking. So these are the basic components that we need to do the image processing, right? Now, what are the fundamental image processing step? First thing will be the I need to do the image acquisition, then I'm going to do the image enhancement, image restoration, then the color image or the grayscale images, then I'll be having the wavelet or the multi-resolution processing, compression, morphological adaptation, segmentation, representation, and the recognition. These are the fundamental image processing steps. Usually output of this each step will be an image, right? So for the image acquisition, how I can acquire the image? Yes, please. Okay, I will have this will give you the clear idea, right? So for the any of the problem domain, let's say that I want to do the crop classification. At that time, the steps what I need to apply is nothing but fundamental steps should be the image acquisition. How I can acquire the images? Yes, please. Okay, is it going to be boring or I'm going
Using
fast?
camera
Yes,
or
the
any
components
data
what we
set
have seen,
available.
right? So data set is also nothing but it is after the what I am saying. These are the outputs, right? The acquisition output will be the images. So data set, what I'm saying, the first thing it has processed is nothing but a image acquisition using the cameras. After that, I'm going to do the image enhancement. I'm going to remove the noise. I'm going to remove the outlier images. Then I'm going to restore the images if it is having few of the data missing, right? Now what it means, let's say that I have captured an image which is having the low light information, right? I have captured it in the dark. Now I need to see it in a bright light. At that time, what I'll be doing, I will be using the image processing algorithm called as a histogram equalization, right? So what it does, it just equalizes the each and every pixel and it will be adding the artificial, you can say, the light into the image so that my particular night image can also appear or the visually appear as a day image, right? So these are the same type of restoration techniques are used by your current cameras also, right? In which they are just going to remove the particular light, they are going to brighten your image or sometime they are going to do the sharpening. All these operations comes under the image restoration or the image processing, right? Same can be applied on the color. Now if I want to play with the color images, I know that color image is nothing but a it is just the 3 channels same as your grayscale images. So at that time processing power needed for the color images will be higher than the regular grayscale images, right? Then I can have the multi-resolution processing, or we have the concept called as wavelet, in which I'm going to divide my particular image into the multiple subplots and I'm going to process it one by one. Another one is another steps can be the compression, in which you are seeing the JPG image, which is nothing but a compressed image, in which I'm going to lose the few of the pixel information, keeping in mind that visually it should appear the as original as the what my human naked eyes can see. But what is the advantages? I'm just going to reduce down the size of the particular image. So compression is another steps in the image processing. Similarly, I can have the morphological processing. If I am applying this kind of operation, image processing operation on the binary images, we'll call it as a morphological processing. Just give me a second. Yeah. Then another domain is nothing but a segmentation. Segmentation, what I'm going to do, I'm going to segment or I'm going to divide my particular image into the sub parts. So similar applications will be, I'm going to segregate or I'm going to segment the object from the background, right? If any of you have seen in an iPhone, you have the feature that if I'm just holding the particular image, let's say I have captured the image, I have just hold a particular person. What it does in iPhone, this feature has like recently came the segmentations. So do in other phone also, right? What it does? Okay, have you tried of the particular stickers? Did you make the stickers from the particular image? Yeah, come on, let's normal question, right? So if I'm just making a sticker, if I want to make a sticker, it's a classic example of your segmentation in which your front object is get divided or it will get separated from the background. So this is called as a segmentation, right? Or then I can also have the description about the particular images. I can have the object recognition inside the image or inside the video. Again, video is nothing but it is a collection of your images only. So whatever we are learning in the image processing is nothing but your computer vision, right? Computer vision, when it comes, it is nothing but I'm playing with the videos, then I will call it as a computer vision domain. If I'm playing with the images, we'll call it as a image processing, right? So these are the basic fundamental image processing steps that I'm going to use, or I'm going to apply it onto the particular problem statement. So depending on the problem, for my crop well detection, I will just acquire the images, I will do the image enhancement, I will do the image restoration if it is needed. I don't need the compression, I don't need the wavelet or the multi-resolution processing. I don't need the segmentation here. I will need the representation with the help of the features, and then I'm going to recognize the object and classify it based on the particular algorithms, right? From this, I'm going to just represent my image with the help of the knowledge base. We'll call it as a usually data set, feature set, and so on, right? That way, I'm going to feed it to the deep networks or the CNN model. Is it clear? Now, what is deep learning now? It is nothing but it is a subset of, yes. Yeah, someone was speaking. Okay. Then what is deep learning? Deep learning is nothing but a subset of machine learning which concerns, it is going to depict or trying to model the human brain in order to learn the features, right? Till now, whatever I have shown, shape, color, and these things, these are the traditional image processing steps that we used to follow, right? In each block, we used to have the different algorithm. Not used to, it is also still exists, and we used to use those like say the manual features. Now what I'm going to do, we are going to use the deep learning to do this task for us. My particular machine learning or the computer is going to learn from the particular image itself. I don't need to do all those things. I'm just going to learn it from the particular image itself, right? Hence, how I can do that? How my human brain works, similar way my deep learning is going to work it. So it is going to program using the layers of the artificial neural networks, which will work similar to your human brain. Deep learning algorithm, it trains machine by learning from the example, right? The examples are nowadays, it's clear applications it has in each and every domain, right? So here a basic block or the processing block for the CNN is nothing but a neural networks. So neural networks is structured like a human brain, which consists of the neurons, which is also known as a node. These are stacked next to the each other. So it has the three components basically, or the three layers: the input layer, the hidden layer, and the output layer. Input layer is nothing but the image or the data, whatever we are going to represent with the help of the pixels, that will be my input layer. Now I know how to represent an image. My image will be represented basically with the help of the values within the range of 0 to 255. We'll call it as a pixel. If I'm saying I'm having the image which is having the height and width of 3 cross 3, I can have how many such pixels into the particular image?
9.
9, right? So this will be the x1 to x9 will be my input to the neuron, right? Then second layer, we'll call it as a hidden layer, in which it's just going to multiply each and every pixel with the weight. I'm going to add some bias in order to map it with the output layer, which is I'm expecting, right? Let's say that I'm saying that those are the handwritten digit recognition, in which one, I know that those image was for the one, so I will have the output label as a one. So these are the things I will be using. I will give the input, that is nothing but a 9 pixels. I will multiply with the weight. Initially these weights will be having the initialization as something called as 111 or some random values, right? Again, these are the already predefined. Then once it is done, I will come back using the regression like we have seen in case of the supervised learning, and I will try to train it iteratively unless and until I reach to the optimal value to the output, right? Once it is done, I will say that, okay, my neural networks has been trained. So basic building block for the CNN is nothing but artificial neural networks only, or the neurons. So each neurons I'm going to work with. So how my deep learning algorithm works, it wide algorithm, it is used to extract the features by learning the few of the patterns. Now what type of patterns? It is going to multiply it with the weight. It is going to learn how my particular one will appear into the system. So I know that this will be the zeros. Most of the things it will have is nothing but a zero values. It will have few of the value as a 255 or the white pixel values. So that type of structure or the pattern, it will be trying to remember it as a particular one, right? During the training processes, each algorithms use the unknown elements, that is called as an input distribution, and is going to map it to the particular output. So it is also kind of the self-learning. Is going to derive some of the pattern. So if I'm just simply representing this as a input scalar, it will be represented as 00255. That is the first three row, followed by the second row, that is the 255 025, something like that, right? So I can observe that the previous part and the end part for the one is nothing but a mostly zeros.
Sir.
If it is yes, yeah, someone is asking something.
Sir, can you explain the concept of hidden layers in neural network and their role in image classification?
Yes, so this part again will come at the time of the flattening, right? Again, we will just go into depth. What I'm saying is my input to the neural network will be then this kind of image, which will be in a flattened manner. What do you mean by the flattened manner? This I'm representing it as a single scalar. Okay, this is a matrix, right? But what I'm saying, my input should be 9 values, x1 to xn. I know what is x now. X is nothing but my pixel, but I'm having the image has the multiple pixel. So these pixels, I will use the command called as flattening to represent it as a 00255, then 255 and the 000. This will be the input given to the neural network, and it is going to map that to the output layer. So in between, if you again want to use the traditional neural networks, you can add the multiple dense layer in between, right? So at the time of architecture, if I'm saying the CNN architecture, what are the architecture? I need to extract the features using the convolution operation. I will be using the flattening operation. This is nothing but my neural networks, right? Just one sec. These are my neural networks, which will be used at the end at the time of doing the classification. If I'm saying this is a car or the bike, so how many classes I'm expecting from my model now here? 2 classes, 1 or the 0. My input, what I have given? I have given a matrix whose length is W into H, having the pixel, which is nothing but a W into H number of pixels. Let's say that my car is represented with the help of the 3x3 image. Then total number of pixels are nothing but a 9 pixels I am having. This is my input. What is my output? I need 1 and 0. How many numbers? I need only 2 numbers as my output. How to reach here? To reach here, I will use the neurons. I will use the neural networks, artificial neural networks, which will be flattening this image. Again, I will update the weight here also to get the ones and zeros. Is it clear?
Yes, sir.
So here internally what is happening? Again, I'm having a simple formula. I'm just multiplying my input with the weight, adding the bias, right? Then passing this to the next level. When I'm saying I'm adding it, what is the output I had? I had 9 input. If I'm adding all 9, what will be the ultimate value? I'm only going to have the one single value, which will be nothing but a W1 into the X1. That is the summation of all the pixels plus I'm adding some of the bias. It can be negative value or the positive value in order to map it to the output 1, right? So this is nothing but a train. Once the system is trained, W1, W2 till Wn will be fixed. Whole sole purpose of training is nothing but to find the values of W1 to Wn in case of the normal neural network, right? Later, in the next slide, we are going to focus on the convolutional layer also, right? Again, it is a neural networks only, right? So don't get confused. The basic block of the neural network is nothing but you can give the input, multiply it with the weight to decide the what will be the values of weight. We'll call it as a training. Once my particular value of weight is been fixed, we'll call it as a testing. At the time of testing, my whole and sole purpose is to map my input image, which is having the W cross H pixel, to the ultimately a single value, which is nothing but a class probability, right? To do that, I need one of the block called as a neural network, which is have highlighted it, right? So far, any doubt? Yes. Okay.
Sir,
Sir,
what
why
will be
we
the
add bias?
dimension of the bias matrix?
Bias will be a single value. This bias is a single value. Okay. Usually
Why
we'll
should we
call
add
it
it?
as a, we are not going to add it, right? Let's say that my value, I can also subtract it, right? What it means, let's say that W1 to Wn, initially I have set it as a 1, right? I'm saying that I'm going to classify my car and the bike. Car, I'm giving the label as 1. Okay. And the bike I'm giving the label as 0. So what I'm expecting, I'm either expecting from my model, assuming that W1 to Wn already been trained. So these are having the values as W is 1, W till Wn, all values are 1. So if I'm just multiplying this W with the input what we have flattened here, right? So what will be the values here? What will be the output of this? How many 255 I'm having?
3.
3. What will be the output of this formula? Multiply each pixel with the weight and then add it. I will show it here. So each pixel with the W is we are setting it initially as a 1. I have added all the pixels. What will be the value? Something around 765. 255. I'm having the 3 times, right? 765. But what is my expected output? Where I'm trying to map it? Either to the 1 or 0, assuming that that 1 what I have represented is my car whose value is 1. So is it possible to map that 765 to the 1? No. So what is my error? 764. So I will add the bias which is equals to the minus 764. Now I have learned this value. I have learned this value from the supervised data available. Is it clear? This is just a one layer again, huh?
We can map it
If
through
I'm
activation functions.
Yes, so this is the activation function, right? I'm not gone into the detail, right? But ultimately, what is this happening here? Because we don't have time actually, right? So here, basic activation function for this type of use will be ReLU activation function in which negative values will get ignored. Here, I have given a simple example where my W value is a 1, which is a positive value. But it is not necessary that my W value is always a positive value, right? But my pixels can be a positive value. This will call it as activation function, which will be used to learn this biased value. A simple activation function, what I have told you, it is nothing but a difference of this. That is the activation function I have used to define the value of bias. Is it clear? There are multiple activation functions. ReLU is a function in which I am just ignoring the negative values. I'm just considering the positive value. This is the one-off type of bias value again. Is it clear? So it is usually a single value pertaining to the particular parameters. This is a single neural network having only one hidden layer. You will be having the multiple hidden layers, so your complexity will be in the order of n. Is it clear? I'm just trying to give you a simple example, then we can relate it with the 2D image processing or the image picture. Is it clear?
Sir, one more doubt, sir. How the weights
Yes.
are optimized, sir? By one or all together at once?
No, it will be all together depending on the error, right? So I am going to compute the errors. You will be having the error or the loss function, right? Whenever I'm learning, what I'm going to learn, I'm going to use the loss functions, right? So I'm going to identify the errors. Accordingly, I will manage or update the weight as well as the bias. So usually, since we are having the high computational systems, it is done at the one stroke only, right? Not one by one, like layer by layer it used to be done. Is it clear? And
Yes, sir.
here, I guess I have already mentioned, right? In a image processing, basic at the time, what I said, image processing, the last line, right? It requires the fixed sequence of operations that are going to be performed on the each pixel, right? So either you will do it on the each one by one. So at a one stroke on the one channel, it is done internally onto the system. Fine. Okay. So in the CNN, you have the in deep learning, you have the multiple architectures or algorithms that is like CNN, LSTM, recurrent neural network, GAN, RBFN, and so on, right? So we are just going to focus for today's session on the CNN only, right? Because we don't have that much time. In future, do let me know. We'll cover one by one each and every algorithm also, right? So CNN usually stands for the convolution neural network. It is also called as a ConNet. It was coined in the 1988. It was used for the normal digit recognition, like the zip code and all that, all the handwritten digits that are going to be recognized with the help of the CNN in the first application, right? So it needs the 2D type of data, that is nothing but a matrix. Hence, it is most suitable for the images, because my image is nothing but a representation of the matrix. Such multiple matrix, we'll call it as a RGB image. A single matrix, we'll call it as a grayscale images. My CNN needs the input shape, which is nothing but a 2D shape, right? Hence, my CNNs are used, my convolution neural networks are used. Now here, I know the neural networks, right? Now, new terms has come is nothing but a convolution. So what is convolution? So if I'm saying the architecture overall, I will have the input image. Again, it is a W cross H matrix. I'm going to use the convolutional layer. I'm going to use the fully connected neural networks. Then we'll call it, I will be getting the outputs. I'm going to use the NN, normal neural networks, along with the hidden layers if required, to get the output or to classify the particular images, right? If I don't require the classification, if I need the reconstruction, I am not going to use this last layer, that is nothing but a neural network. I'm just going to use the convolutional layer only, right? So depending on again the applications, I'm going to add these layers, right? Now what do you mean by convolution? Convolution's whole purpose is to extract the feature, right? Now what I know, what do you mean by feature? Feature is nothing but I'm going to represent my particular image with the help of the few of the characteristics. Like for the apple, my characteristics were shape and the color. Similarly, CNN gives me the leverages, gives me the advantages that it is itself going to extract the feature, is going to learn the pattern. I don't need to do anything. That's why nowadays we are focusing more on the CNN. So it has made our job easier, right? So main objective of convolution is to extract the feature such as edges, color, corner, and so on. Now how it is going to again extract? Again, it is going to extract the mathematical value only, nothing like new into it. Convolution was existed, it was there. Only thing was we didn't had that much computing powers. My computers were not able to only handle a single arithmetic operation, hence we have not picked up on the convolutional part. Now since we have the GPUs and the high-end computers, my CNN has picked up, right? So it will learn the specific pattern from the images, it is going to learn the features. Now, what do you mean by convolution now? Convolution is nothing but if I'm having the input image, I will have a filter. Filter is nothing but my weights. I will just filter, or I will move this filter on the input to extract the feature, right? So this process will call it as a convolution. That is nothing but multiplying my filter with the input image one by one to get the output. That output I'm going to call it as a feature map. Now here is my input image. Let's say it is an binary images in which my pixel values are given as 0 and 1. Now 1 is nothing but a white pixel, 0 is nothing but a black pixel, right? So I'm having something like this, some of the kind of the image which is represented with the help of the pixel, right? So if I'm just visualizing it, it's kind of some kind of this kind of shape, right? Convex shape kind of thing image is there, right? Now from this image, if I want to extract or learn the features, how my convolution layer works, it multiplies it with the filter. So this filter will get overlaid onto the first 3 by 3 matrix, multiply each with the filter, each pixel with the filter, and add all the values. So first is nothing but a 1 cross 1, then I'm having the 0 into 1, then 1 into 1, and so on. So it will give me the value as 4, right? Next, try to put this particular filter on this particular next value. So what will be the feature value I'm going to get? Is it clear how my feature map has been deduced? Multiply each and every, overimpose this filter onto the this 3 by 3 cross matrix, my input image, multiply each pixel and simply add it, similar to the neural network what we have seen. So here onto the highlighted box, impose this filter wherever my values are mapping, multiply it, add it, and tell me the what will be the feature map value I'll be getting. Okay, I guess we have to see example also. I will just rush it up a little bit, right? So if I'm just taking it for the first, if I'm imposing my filter, I have represented with the help of the red marks, that is 101, 010, 101, right? Earlier in neural networks, I used to have the filter W value as a single value. In a CNN, since I'm working with the images, my filter will be of the size n cross n, right? So after imposing, just multiply those values element by element, add it. I used to get the 1. If I'm just moving it, I will get the next value, and so on, right? So likewise, I will be doing the multiplication with the filter, add it. This process will call it as a convolution, right? So in case of the training, what are the operations when I'm saying conversion? What are the basic operation I'm doing? Only the multiplication and the addition. But the scale of the optimality is very, very high because my image size will be usually very, very high, 200 cross 200. And for each pixel, I'm going to multiply it and do the addition. Hence, these are requires the much time to learn the features from this. Now, these are the values what I'm getting This will call it as a features, right? Similarly, if I want to apply the convolution on the 3D image or the RGB image, how I'm going to do it? How many filters are required if I want to convert the RGB image? Yes. For the grayscale image, how many filters I have used?
One.
One filter of size, some 3 cross 3. I can also use a filter of size 2 cross 2. Again, that is the property of your image processing, a traditional image processing, that if my filter size is higher in the dimension, let's say 5 cross 5 or the 10 cross 10, in that case, it will not be extracting the feature, it will smooth the image. What do you mean by smooth the image? It will blur your image. The blurring part, will call it as a smoothing. If I'm getting the exact age information, we'll call that process as a sharpening process, right? So smaller the filter size, better will be the feature map for the particular image. Hence, usually the recommend is that whenever I'm doing the CNN model, my filter size should not cross the 5 cross 5. I can go till the 3 cross 3. You can also use the 2 cross 2. You can also use the 1 cross 1, that is the actual weight filter, but in that case, again, the complexity of training will be very high. Hence, we do not take 1 cross 1. We usually take 3 cross 3 or the 5 cross 5 filter, right? Depending on the application, you can also take any of the size of the filter. But remember that more the filter size, the worst will be the image, it will be the smoothen image, right? So similarly, for the RGB images, I will require the 3 such type filter. Either you can use the same filter or I can use the different values of the filter. Yes, someone is raising hand. Shivam. Yes, Shivam.
Sir, so the filter matrix will be the dimension of the filter matrix will be same as the convolved layer matrix, convolved features matrix.
Convolve, no, dimension of the this, okay.
Filter
Filter
matrix.
is decided by you, right? Whenever I'm doing the programming, it will be decided by you. Here again, you are having the hyperparameter called as a stride. What do you mean by stride? How we have moved this filter? Initially, this was there for the 1, 2, and 3. Then I have moved the yellow part 1 pixel on the right. Can you observe that? Right? Then again, I have moved it on to the right. If I'm adding the padding, right? My initial pixel size was, my image is having the how much WNH? 6 cross 5, right? My convolved output image is of size 3 cross 3. This is because I have not added any of the stride or the padding to this particular image. You can, if you want the same size output, you can add the padding or the, you can increase the stride. What do you mean by padding? I will just append this remaining pixel. I will just increase this size to the 0, 0, 0, right? Here I'm padding the zeros or the ones. That is nothing but there are two types of hyperparameter, that is called as a stride is same or stride as a 0. So if I'm saying same, this same values will get copied and my filter will start here somewhere else, right? At that time, my size will be one more pixel greater than this, right? So if I want to have the same image size, then I will add the padding. Usually by default, these are the settings that are there inside your CNN. Hence, it doesn't have anything to do with the filter size and the output size. It's purely depend on the hyperparameter, how you are setting. Is it clear? And this filter size you can specify. What I'm trying to tell now, this 3 cross 3 filter what I have used, this size I'm going to specify it inside the convolutional layer. All the parameters can be set. Yes. When I'm going to see the example at that time, it will get more clear again. Have I answered your question?
Yes, sir. Yes, sir.
Yes, sure. Yeah. So this will be filter for the RGB. I can have the 3 such filters which is having the dimension as 3 cross 3. You can also have the 2 cross 2. You can also have the 5 cross 5 filter, right? Nothing wrong in that. But the higher the filter size, worst will be your result, right? So how in image processing my filters are look like? Here are the basic filter example. If I'm using the identity filter in which my middle value is 1, rest of the values are 0, then it will give me the sharpened image or the enhanced image, right? Similarly, if I want to detect an only edge, like we used to detect the apple का shape मुझे अगर चाहिए, if I want to extract the shape of the apple, I need to detect the edges. So at that time, I will use the filter which will have the values which is having the negative values also, right? Similarly, if I want to sharpen my images, in which you can see the difference between the first image and the sharpener images, in which it is giving me the more crisp information. So at that time, I will be just having the maximum identity value as middle value will be the higher one. Rest of the values will be the negative values, which will give me the sharpening filter. Similarly, if I want to remove the noise, I will do the blurring. Similar blurring is nothing but a multiply each image with the 1 and take an average. How I can take the average? Multiply it, each will be the 1 and divide it by the 9 gives me the blurring effect. That is nothing but the average gives me the blur. Similarly, if I want to have the Gaussian value, Gaussian blur, more kind of a blur in which my information should not get like lost, I can use the Gaussian blur. So these are the specific some type of the filters that are there in the traditional image processing, right? These images we are going to use it to multiply it with the input image in order to extract the features. What is features? If I want the edge, the right side third column what you are seeing, this is nothing but a feature map for the particular image, right? From these features, my particular system is going to learn the filter. Now in the convolution layer, what it happens usually, the filter what are there already, these filter are going to learn by itself. That's why CNN has taken the that much of advantage or that much of attention from the all over the world, because my filters are going to be decided. These are the standard filters, right? These are the values which are already been given by the particular some scientist or the academician depending on the particular experimentation, but it need not to be the same for each and every application. Hence my CNN will modify this filter value, right? Next layer will be next component I will be having is first component was a convolution layer, sorry, second is a pooling, third is a fully connected layer. Fully connected is nothing but your neural network, and the next important layer in the CNN network is nothing but a pooling. So pooling is, it is solely used to decrease the computation power required, because computation is very high. I need to multiply and do the addition. Multiplication takes the too much of time. Addition, though it takes the smaller time, but when you are doing it, applying it on the n cross n images, it is very high computation, right? So to reduce this dimension, we will be adding the pooling layer in between. If I found that, okay, at some particular layers, I have extracted too much of information which can misguide my particular model, at that time, I will just simply add a pooling layer. So it is nothing but it can have the different types of pooling, that is the max, average, and the sum. As name suggested, what you are expecting now? If I'm saying the max pooling, I will just again apply the filter dimension and the stride. Stride is nothing but how my filter is going to move on to the right side. Earlier, by default, my stride was 1. When I'm saying stride is 2, you can see the color boxes. My filter size is 2 cross 2. And my pooling operation, what I have used is nothing but a max pooling. So what it indicates, I will just multiply it with the filter. I will take the maximum value among the particular filter size. So first color, you can see filter is a 2 cross 2, maximum value is a 6. Similarly, next value is a 8, then the 3 and the 4. So this is my max pooling operation. Why I'm going to use the pooling layer now? Yes.
To reduce the dimension of the convolved layer.
So initial my dimension was 4 cross 4. It has got it has got decreased to the 2 cross 2, right? So this, for this region, I'm going to use the pooling layer. It's not recommended that you add a pooling layer to the each and every conversion layer, right? Because again, in that case, I will be also losing the information. But sometimes too much of information to the model is also hazardous. It is not recommended. Hence, I'm going to add the pooling layer in between. So what are the important layer? First is the input layer, second is the conversion layer, then third we have seen the pooling layer, right? I have used the max pooling. If I'm using the sum pooling, what will be my output? What will be this first value now?
13.
13. Next,
21.
21. Then 8
8.
and
8.
8. Right? So these are the few of the types of values I'll be getting, right? Again, depending on the which function you are using, you can choose any of the pooling layer. Again, it is experimental, right? So I can have the different types of pooling, max, average, and sum, right? These are the classic example of the pooling. Pooling will be used to decrease the dimensionality. Fine. Now, till now, we have seen the architecture. I have I have taken the input, right? I have used the convolution layer. I have added the pooling layer. Now what I need to do? I need to map it to the single output. That is, we are going to see it for the handwritten digit recognition, right? So I need to classify the particular, this value, whether it is 1 or 0, right? Or 2, 3, something like that, right? I can have the 10 digit. Hence, I will be using the last layer whenever it is the matter of the classification called as a fully connected layer. That is nothing but my neural networks, right? So here I can add the multiple hidden layers, and then it will map to the particular dense layer, which will be mapping to the number of outputs or the labels that are available inside my databases, right? So this neural network, how it works, we have already seen, right? Now to give this input as a single pixel, I'm going to use the single command in the Python. We'll call it as a flatten, right? So once the flatten is done, I can use the neural networks with the help of the dense layer. Dense layer is nothing but a single hidden layer that I'm going to add. So you can add the multiple dense layer, and final hidden layer will be nothing but called as a output layer, right? Is it clear? Architecture of the CNN. I'll be having the input image. I'm going to extract the features. Again, like we used to train, while training, I need to have the biases. Those biases will be learned from the activation function. Similarly, with the convolution, I am going to add the activation function. We'll be going to use the ReLU activation function for the image processing domain, because my pixels values are always a positive value. ReLU is an activation function which ignores the negative value and it only considers the positive value, right? So accordingly, bias will be added to your particular pixel values. So I'm going to use the convolution. What will be the output of the convolution? Feature map is the output of the convolution layer. Then I'm going to use the pooling. What is the use of pooling now?
Dimension reduction.
Dimension reduction. Hence, in the image, it has shown the feature map in a smaller dimension, right? Again, I can convolve it. I can extract the multiple features. Now, at the time of convolving, I will be changing the number of filters. I will specify the number of filters. Accordingly, number of channels will get increased, right? At the end, since I want it to categorize into the sum of the categories, let's say house, boat, tree, or cat, I'm going to use my normal neural networks, I'm going to use the pattern which will give the input as a single pixel value to my neural networks. You can add the multiple fully connected networks or the hidden layers, and it will ultimately map it to the output layer. Right? This is in case if it is a classification problem. If it is a reconstruction problem, at that time, I'm not going to use this fully connected, right? At that time, this feature map will get reduced down using the pooling to the particular labeled image, right? In which I'm going to reconstruct it. Excuse. So depending on application, the basic application is a usual application is a classification. Hence, I'm adding the fully connected layer, right? So take a 2 minutes break or 5 minutes break. I will set up my, you can just start your system. You make sure that you are just going to the Colab, right? In a Google, just put Colab. All are aware with the Colab? Yes. Then first link will be the welcome to Colab, or I'm just going to copy it. Yes, yeah. One of the question I can see is that how my CNN or the neural network handles the different sizes and the type of images. Neural network usually takes the flattened type of data, so it doesn't need to bother about the sizes. Whereas my CNN at the time of training, always I'm specifying the input size, right? Input shape. Usually the input shape will be fixed. At the time of testing, it can be of any of the input, right? Whereas at the time of training, it needs to be a simple fixed kind of size of the input image, right? Have I answered? Yes, I guess Alicia. Okay. Take a 5 minutes break or so if you want, and reboot your system, log into the website, or sorry, use the browser, log into the URL. I have pasted it in the chat box. It will open the Colab. It just need your Gmail account. Nothing is required. Just click on the file and the new notebook. And this here, if you are clicking on the code, it is nothing but your normal Python single line code. Whereas if I'm keeping on the text, it where I can just write the text, right? Each cell I'm going to run one by one, right? So all are aware of the Colab? Yes, please. If not, then we'll just quickly in 5 minutes, we'll touch it on. Okay, now then the second part, okay, we are running out of time. We are going to provide the summary. We are going to design a CNN model for the handwritten digit recognition, right? So to summarize it, we need to provide the input image to the convolution layer. Take the convolution, it will learn the features, apply the pooling layer to reduce the dimension, add such types of multiple layers to improve the accuracy, use the flatten layer to get the output either into the categories, right? Now train this model by using the command that we are going to see it. It uses the regression to update the filter weights. Either you can use the Jupyter Notebook or Google Colab. If you are in the offline mode, you can use the Anaconda, in which you will have the Jupyter Notebook, which has the similar appearances, right? Which will work in offline mode. You just need to install the Python and these packages. These packages will be installed with the command called as pip install followed by the particular package. So package I need is NumPy, Pandas, TensorFlow and the Keras, right? Matplot library to plot the particular images, right? So these PPT, if needed, I will share so you can learn it. Advantage of the Google Colab is these libraries are already been installed, so we don't need to do the installation separately. Keras is already installed, but if you want to do it onto your system, you just use the pip install Keras. Here, if I want to run a Python command, a normal command prompt, then I will be using the exclamatory marks. Otherwise, these are nothing but a normal Python commands, right? So any doubt till now? Shall we take a break or shall we move with the demonstration? Please let me know. Yeah, in chat box or somewhere. Do we wait for 2 minutes, 5 minutes, or shall we move towards the? Because I need, you can just type it one by one so
we can
that
move
you
forward.
can run. Okay, sounds good. So we are just going to do the whatever we have seen. Those steps only I'm going to use it in the code in the handwritten recognition, right? Digit, you know that it will be having the categories classes as 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Total 10 classes I'm going to classify the particular image, whether it is a 1, 0, or something, right? I'm not going to consider the complex digits such as 10, 11, 100, and so on, right? A single digit, I'm saying that I'm going to design. Later, you can just modify this code and try to, as a small project, try to port it for the multiple digit image also, right? Sounds good? So first thing will be, we are going to import the libraries. So basic libraries that I'm going to use is nothing but a Keras, which will be a TensorFlow model, which will be used to design or to use the functions to add the particular layers. So I need, how many layers we have seen? What are the components of CNN? Convolution neural networks, right? ConNet, followed by the pooling, followed by the flattening or the fully connected dense layer, followed by the first layer will be the input layer, right? So I'm going to use that from the Keras model. I'm going to import the layers. That is nothing but a dense layer, convolution layer, and the flatten layer, right? Pooling will be already there. So it is already the part of your Keras library. So I inputted the libraries that are needed. I'm going to plot it. I'm going to visualize it. To visualize it, I'm having the matplot library, which will be used to plot the particular image onto the screen, right? So this is just for the visualization. Now my data set is already available inside the Keras itself. So from the data set, I'm going to use the MINST data set, which is the digit handwritten digit data set, right? Then I'm using the utility to just format my input in a categorical manner, right? So the input what I'm getting is having the label as 1, 2, 3, 4 till 10. I don't need like that. I'm going to represent it in a matrix in which if it is a 1, my first label will be set as 1 and so on, right? So that will see it in the upcoming cells, right? Once it is done, you can just click on the play button. If it is not having any of the dependency, if all this Keras is already been installed, Matplot is already installed, it should run and it should show the green tick. All are we on the same page? Yes. So later, I'm going to import the data set. To import the data set, I'm just going to use the MINST package. From that, I'm going to use the command called as dot load data. So how it is going to load the data? It's going to give me the training images followed by the training label. So I'm just renaming it as a Y train, X train, then X test and the Y test, right? So test image, test label, train image, train label. Now if I want to show any of this image, I'll just run it. So it is going to download the particular data set into your directory. So it is not that much, it's some 2-3 MB data set, that's it. 11 MB, I guess. So it will take a while. Once it is downloaded, it will show you the tick. If I want to show the images, I will use the plot that is from the matplot dot IAMShow function. I will pass the particular image. I know the arrays, how it will be worked because it is a traditional NumPy. So I will be using the xtrain and followed by the index, right? So if I'm just visualize it, the first image it is having in the training set is something kind of 5 digit. Let's say if I want to have the 100th image, I can just have the visualize the 100th image. It is nothing but again the 5, something called as 1,000 image. So it is a 0 kind of this kind of images are already available. Now to train my model, what I need to know? I need to know the input dimension, right? So how to know the input dimension from the particular NumPy array? So it is nothing but a matrix, right? So which function we know? We have covered NumPy module in the Python, those who were there in the first year, right? Anyone? How to know the size of this matrix or the NumPy?
Dot shape.
Shape function.
Dot shape, right? Exactly. So I'm just going to use the print extend 0 dot shape will give me the size of the image. Image ki size क्या है? What is the size of image? 28 cross 28, right? Similarly, shape of my training, how many images it is having now? Now first dimension, it represents the total number of images followed by the size of the images. My image is always of size W cross H. So is it a RGB image or the grayscale image now? I have in the first line, I have printed the shape of the single image. Here.
Grayscale image.
Grayscale, because I'm only having the W into H, I don't have the channels, so it is a grayscale image, right? Then I'm having the total number of how many training images? 60,000 training and the 10,000 testing images. Is it clear? Why I need to know about the shape? Because my first layer to the CNN architecture is nothing but a input shape, input image, right? After that, I'm going to apply the convolutional pooling and so on. Till now, any problem? Data pre-processing. So now I will reshape my data according to the CNN model. So I will reshape it as a 60,000, that is the number of images followed by the dimension. Since it is a grayscale image, I have given the third parameter as a 1. If it would have been a RGB image, my fourth parameter, that is the last parameter, would have been third, right? Since it is a grayscale, I have given the total number of training. I am saying that whatever type of data I'm having, reshape it to the 60,000 training images followed by the image dimension followed by the channel, right? So in multiple libraries, if you are using the pandas and all that, these channels are coming onto the first. Here in a Keras, my channels are represented at the last. So this is just a representation how you are going, right? In order to represent a particular image, for the further processing, you need to do the reshaping, right? So I have reshaped it to the X train and the X test. Similarly, my Y train and Y test, I said that those are the single values. I'm going to represent it into the 10 output hidden layers, right? So those layers, we are using the method called as two categorical, in which my first image was a 1, 2, 3, 4, 5 image, right? So fifth, I have just put the value as 1, remaining rest as 0. So it will represent it like this. Similarly, my 1,000 image was the 0 image, right? So 0, you can say that, sorry. Yeah, so my first image was a 0, so it has categorized it to the 0th image. And if I'm just printing the 1000 image, it will categorize it to the 1000th image, right? Categorical representation, it will represent. So currently I'm representing all the images. Similarly, you can just change the output format, right? Once my output format is done, I'm going to build my model. Now, always my CNN model will be a, for image processing, it is a sequential model in which I can add the one layer at a time. If you need some different architecture, we have the various number of architecture, you will change the model direction, right? So usually it will be a sequential because I'm going to add the each layer one by one, right? So first layer I'm going to add is a convolutional layer having the kernel sizes as a 3x3. Activation function I have given is a ReLU. Input shape to the first layer I'm specifying explicitly as a 28 cross the 28 by 1. So someone was asking how my CNN handles the different size of images. So to handle the different size of images, I need to pre-process it. I need to give the training images which is having the same size as W and H. If it is having the different sizes, it will result into the error. Hence, we have done the reshaping. We have reshaped the images to all to the 28 cross 28 by 1 channel. Now, how many such filters I'm using? 3x3 filter, total 64 filters I'm going to use, right? Again, I'm adding the one more convolution layer. Now, I don't need to specify the input since I have said that my model is a sequential model. For the second convolution layer, it is going to take it the input from the first convolution layers, right? For the first layer here, I need to specify the inputs explicitly. Hence, I have added the one more parameter called as input shape, and I have specified the input shape, right? One more convolution layer I have added. Now, if needed, you can add the pooling layer. Then you can use the flatten to just flatten the particular output, right? Once the output is flattened, I'm going to flatten it to the 10 dense layer or the 10 output layer. Hence, I have just added the one hidden layer which will directly map it to the 10 output. That is the 10 classes that I'm going to need, right? After that, I'm just going to run this in order to make sure that, okay, it is working fine. It has, once it is done, it will show you the green tick. Now, if I want to visualize my model summary, how are the model look like, it will be used with the help of the dot summary command. So dot summary will be telling me what are the layers I have used, what are the dimension, how many learnable parameters are there. All this information will be there. Now, how this learnable parameter has come? It has just multiplied it with the dimension, that is the each pixel. So for this conversion layers, if I'm just going to add it, multiply 24 cross 24 cross 32, it gives me the 18,432 and 32 were the bias. Hence, my total learnable parameters are the 18,464 for the second layer, right? Similarly, once you are flattening it, this entire images having the 32 channels will get flattened, will get fed it to the hidden layer, which will output the ultimate 10 such probability value, right? Once my model has been done, I'm going to train it. So to train it, I'm going to use the compile command. You can use the different optimizer, different loss function, and you can train it for the accuracy, right? Once it is done, once my model has been compiled, I need to train it. So in order to train, I'm going to use the fit. So as soon as I'm using the fit, you can specify the, sorry, just a sec. Okay, if you are keeping it idle for the few number of times, it will lose the information, right? So again, you need to run the particular cell. So I given the 3 epochs, right? Earlier, since I was streaming it on the MS team, I have not run the previous cell. It has disconnected. It has shown the error because it didn't got the information for X10 and Y10, right? So once it is done, it is going to train it. It is going to show you the actual accuracy at the time of training the system. So here I have just specified the 3 epochs. The more epoch you are giving, better will be the accuracy of your model. What I'm going to do, I'm going to do the training data, training label, then the validation data set, just to check how much is the learning for the particular model, right? Till now, is it clear? So what I can do is that I'm just downloading it. Just give me a second. Okay, the same file what I'm working, I have uploaded into the chat box. Download it because we are running out of time. So just you can open that file, go to the file, open notebook option. Here you will have the upload option. Choose that particular file what I have just uploaded into the drive. So you can choose that file. Once it is done, the same file what I'm working, it will open, run each and every cell, and you can see the output till 5th stage. Can you do that, please? Yeah, everyone has at least came till the 5th steps, that is the training the model. Yeah, I'm audible. Hello.
Yes, sir, you are audible.
Yeah, so file is there, right? All are able to download. Download the file, go on to the file, upload or open notebook, click on the upload, choose that file, right? Once it is done, click on the OK or open, right? Some option it will show, it will get open. Click on the each cell. Don't run the first cell, it's not needed because already Keras is installed. It will consume the time, right? Run this coding each and every cell, and do let me know once you are at the training layer, right? Once my training is done, we will visualize the particular output. Okay, take a time, 2 minutes. It should not take that more than that. Yes, anyone has reached till model training, model fit?
Yes, sir.
Okay, sounds good, right? Next, if you're running it, if I'm running the prediction, you can observe that we have chosen the categories, right? So I have given the 4 images in which I can also use a function called as a argument max to identify which out of this 10 column it has identified, right? So it has identified the 4 images from the test set, first 4 images, which is having the label as 7, 2, 1, and 0, right? Let's try to visualize it, how it looks like. So I have given my test images, nothing but this type of images. I'm just going to subplot it with the help of the matplot, right? So 7, 2, 1, and 0, it has correctly identified as a 7, 2, 1, and the 0, right? Now those who have already been run this thing, here I have given simple modification, right? I am here for 5 minutes. I will take questions if there are any. try to do this modification, right? So this CFR dataset is available in the keras.cfr10, right? So just change the dataset is available from in the package called as keras.dataset import CIFAR10. It's having the all these total 10 classes, airplane, automobiles, and so on. Try to modify the particular code what I have just shared, right? Again, to tell what things I need to check, my input dimension, input shape, and my output classes. Then again, later you can also try to improve the model accuracy by trying to add the multiple layers, right? So with it, we'll try to summarize it. Further part, again, I wanted to just give a short introduction about the other models. Maybe next time we will just focus on those models also, right? Sounds good? Yeah, just want to know, are you getting a little bit confidence in the CNN network? Is it clear?
Yes, sir.
Yes, sir.
So quickly, 5 minutes, try to make or try to modify that code for the CIFAR 10 dataset. What change you need to make? In a package, the first stage, loading the dataset. Before that, loading the package, load this package called as from Keras dataset, import CIFAR 10. After that, load the dataset as CIFAR 10 dot load a dataset, right? Instead of MINST, it should be CIFAR 10. And I am having the total 10 classes. For hand recognition also, we had the 10 classes, so nothing to change much, only a few changes you need to make. What I need to change? You need to change the input shape. If you are also not forgot to do those changes, it will show you an error in which will tell you what error it has given, right? So just do the changes and do let me know what is the accuracy you got. We'll keep the model same so that we will test it. Okay, any doubt till now?
Anyone having any doubts can interact with the speaker. You can unmute your mic.
Okay, since time was very less, maybe in subsequent sessions we will try, right? If time permits, we will take different models also. This is the basic CNN model usually used for your particular image processing, right? That's where we have covered. And if you want to add the pooling layer, you can use the model.add command. Add is a function usually used, and you can just import the max pooling 2D, right? So from the Keras, you will just add the max pooling layer and you can use that. So here I will just add if I just need the one more layer, from the layers, I will just add the max pooling 2D. Like we have used the convolution 2D now. So likewise, I can also add the max pooling here. So it will be model.add, and here I'm going to add the max pooling layer, right? So what was the use of the max pooling, by the way, or the pooling layer?
Reducing the dimensions, sir.
To reduce the dimension, right? So I can just add it something like that. If I'm using the max pooling, what it indicates, I'm using the max pooling with a filter size as 2x2. From the 2x2, maximum value will be considered, right? This layer currently I'm not adding. I'm just putting it as a comment. I will keep it here so that you can just use it later time, right? So anyone has tried for the CIFR? Okay, what are the changes I need to make? Here instead of MINST, it should be CIFR 10. Okay, if no doubt, then we will conclude this session. Before concluding, just do let me know anyone has modified the code. If not, then also no problem. I have the modified code. I will share that also, right? But before sharing, I just wanted to know whether anyone has got the output or not. Yes, anyone? Okay, so first change I am expecting is here in a first stage, loading the package. Then here CFR10 instead of MINST. Now, please tell me what are the dimension of this data set. Whether it is a grayscale image, RGB image, or RGB image.
RGB image.
RGB image, right? So what I need to do, that's why I have checked the shape. Once shape has been checked, I can also check the particular shape of the extend and the extend and the X test. How many images are there? So in here, I don't have the 60,000 images. I have the 50,000 for the train, 1,000 for the test. Dimension here is 32 cross 32. Earlier we had the 28 cross 28 and the one channel. Here I'm having the 3 channel. So if I are running it, again categories will remain same because I'm only having the 10 categories as similar to your particular hand recognition, right? Here, change the input image size. Instead of 28 cross 28 cross 1, I'm going to give the 32 cross 32 cross 3, right? Then again, train it. So it should get some accuracy. Obviously, you can just run it for the multiple times. Play with the epochs, change the epochs and check the accuracy. So here was the, okay, I have not run it. Okay, I'm going to disconnect the previous session. Okay, if you're running it, you should see the output images, right? So this is a kind of the images, just having the some boat and some kind of aeroplane boat kind of images into it, right? So any doubt till now? Yeah, just. Okay, I'm stop presenting. Yeah. So just give me a time. I will share, I will download this image also. Yes, the solution code is also available. You can use it, just play with it, do the changes, change the data set, load your images, and the rest of the architecture will be same. Right? So any doubt till now? If not,
Sir,
then we will stop.
can you
Yeah,
share those
please.
PPTs?
PPT, okay. I will just put it here. Or I will share it on the WhatsApp with the organizer, then she can, I guess, give it to you. Is that fine?
Okay, sir. Okay, sir. I'll share.
Right? Both the file already IP5 is there. I will put it on your WhatsApp.
Done, sir.
Yeah, okay. So shall we stop then? If you have any doubt, feel free to drop a message on my WhatsApp or my mail, right? Usually I will give reply to the mail very fast rather than the WhatsApp. Fine?
If anyone want to share your feedback, you can share on the guest lecture actually.
Yeah, that would be great. Okay, so I'm giving my mail ID. Yeah.
This has been a very useful session, sir. I have taken the course Deep Learning and it was very helpful for me to learn about CNN. Thank you for being so patient and teaching us, sir.
Yeah, I don't know whether because of the restriction of time, I tried to do like give the more of the input because I was not knowing what you were knowing. Few of the part I might have repeated also. So sorry from my end. But I hope basic model is clear, right? At least you can able to run an application on the images. Yes, I can expect that. Okay, I have given my mail
Yes,
ID.
sir.
Yeah,
Covered
so I have kept my mail
really.
ID. For any of the help in the modeling or something, architecture you have got stuck, you can always reach on my mail ID, right? Yeah, thank you, thank you. After a long time, yes, I guess almost 1 year has happened. I was not in touch. Okay, then we'll stop. Do let me know if you need any help in future also. Yeah, be in touch. Drop a mail in case of any of the help, right? So thank you from my side. Shall we stop?
Thank you, sir. I want to express our sincere appreciation for you, sir. Thank you for gracing with your presence and sharing your all the knowledge on the topic, sir. It's been very useful for us. We are third years, so we have deep learning in our semester, and some of the topics of our syllabus are covered by you, sir. And I also thank the MLC Club for having this event, and everyone, thank you so much for attending and showing your patience in having the knowledge on CNN. Thank you.
Yeah, thank you. Okay, so we'll stop. Have a happy holiday ahead, right? Thank you. So shall I leave? Is it fine? Yeah,
Yes,
okay. Thanks.
thank you,
Thank
sir.